So hi everybody and welcome back to C++ tutorial series for absolute beginners. This is video 265 and in this video we want to talk about the final specifier. And let's read here the first sentence. It says specifies that a virtual function cannot be overridden in the derived class or that a class cannot be derived from. Okay, and before we go here to the examples, let's go also to the syntax a little bit. And here at 1 we have a pure specifier, which we have not talked or now, which we will talk in the next video, which has to do something with abstract classes and with this equals 0, which is a pure specifier of a function. But more about that in the next video when we talked about abstract classes. And then we have here the second one, which says declarator. Declarator, it's just our declarator. So it starts, for example, in this case a function declarator with virtual void whatever, and then we have here this specifier sequence, and this one we have to read what this is. And when we go down here in this part, we can see it is either override or final, and actually this override we already know. So this we have already used this override with virtual functions, but now we know we can use final as well. And then we have here the function body that would be for virtual functions. And the third one is not with functions. The third one is with class, because we have here two use cases, one for class, one for functions, like they said here on top, with different, little bit different, almost the same meaning, just different use cases. And you can see we need the class K, which means just a struct class or something like that. And then we have here attribute, which is optional. This is again our compiler instruction, most time, not all time, but most time. And then we have here class head name, which is just the name of the class. And then we have again our class virtual specifier, which means we are using, and here very important, override we can't use here. We can only use final. There is no override. So this one here with classes works only with final. That's very important here. And then what we have here, base clause, yes. And the base clause is just when we use inheritance, colon, and then the base classes from what we inherit, means the base clause here. So let's make an example to see this more in action. And like I said, the first one we skip is just for abstract classes. And we go here down, 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 down. But of course you can read here the explanation as well here a little bit on your own. But I jump here first to the examples, but I'm not using this one. We talk about this one in a moment. I go here where it says examples, and then we go here. So you can see they are creating here a struct base, creating a virtual function in it. And then they are creating again a struct, and they are inheriting. And by the way, this is the base clause, what I mentioned here. You start with a colon, and then you are saying from what you want to inherit. And then again, what is that for inheritance here? It's public. How I can see this? Because the struct has a default public inheritance. That's why. Don't forget this one. And then we see our function here, and this one is what? It's a virtual function. How I can see this one is a virtual function? First of all, you can see it now with the new word final, because this is only allowed with virtual functions. And you can also see it that we already have defined it here virtual, and it's a foo, and we are overriding it. But important is you have to know here is an invisible virtual, and here is also an invisible override. This is still an override. It's just the final override. Okay. And then it says here base foo is overwritten. Yes. Here's an invisible override. And a foo is the final override. Yes. This one is our final. And final override means if we try to override this one in another derived class, we will get an error. All right. So far, so easy. What is this one? Why it says here an error? Before you read this comment here, it says here an error because We're using here final, and I said final is used with virtual function, but the problem, this function here was never marked as virtual. So for example, in our base, there is no bar which was virtual, and we have also not marked it here as virtual. We could write here virtual void bar final, that would work, but that's also not marked here, so that's why this one is an error, but cannot be final as it is non-virtual. Yeah, so far so clear. And let's go here to the next example. It is struct B, but this time we use the word final with class and struct, and we know they are used a little bit different, but in this case they have the same meaning. So final means here, this struct here from this one you can't inherit anymore. If you try, you get an error. But what we have here, we have again here our base clause which says we make an inheritance from A. Is this allowed? Yes, it is, because here is no final word. So we can see we can inherit it here. Again, this is a public inheritance, and here interesting is look at what we have here. But careful, why it says an error. Easy now to understand why it says an error. It here, this one looks very fine. It's void for override, like syntax okay, but the problem here is here in our struct base from which we inherit, because here it was marked as final, which means this function should be not overwritten again. That's why we have this one here. And then when we go here to our last struct, say it says here an error, but now that's also very easy, because you can see struct C, this looks absolute okay, but when you go to B here up, it says final, and we learned final means with struct you have not the right to derive from it, and if you try you get an error. So you can see the examples very straightforward, not very difficult. You have all time check most time the base from what you inherit. For example, like you can see here I have check B from here to here, and if I have a function, for example here, if an error, then I have checked again the base what it says, and if it says here not final, it could still go up a little bit, because perhaps it says not here final, was final in other place, and we still overrided it 3 times accidentally. Who knows? But not too difficult, I think. But here is a problem with the word final, and we will talk about it right now, which is here in this node section with this strange code what they provide here. What is the problem here? The problem is this word final is not a keyword. Why is this a problem? Because if it when a word it is a very important word actually in C++, we can see it, we use it here in derived classes, but the problem, like I said, it's not a keyword, means we can use this word final as a name for variables, or even a class name for a type now, and that can bring much confusion, and they show us here the worst code what you can mess around with them. This is just for demonstration purposes that yeah, you can really abuse it more or less. And let's go through this one now. So here they struct with what is that here? Struct A, very simple. Do you remember? It's a forward declaration. And what is this? This is just the forward declaration definition. We can see struct A, but we have here the word final. That's very important. So we can see we have the word final here, and final means you should not inherit from this one more. And it says here, okay, definition of struct A. Yes, this is a definition. We see why is this a definition again? Of course, we provide a body. Here we have not a body, forward declaration. Okay, not value initialized of variable final. Not value initialized. Yes. Okay. Then we have here struct X. So let's say we are creating again a struct, and this struct X has here nested structs. We have here struct C, and then we have here the body, and we have not talked about this one in detail, but I think you should just identify it, perhaps not understand it what it is in detail. What is that? Okay, when you see this operator here, then you should make operator overloading. But in this case, we have not talked about this kind of operator overloading. We have just talked in general a little bit about operator overloading. And this operator overloading is what kind of is this called? I don't know the real name, what is called. It's a conventional operator or something like that, which means, in short, this you can create here a C object, and then you can assign it to a int variable, which means I have here int I, let's say I, and then I assign it to C, and C will return automatically 5, which means my int I becomes 5 when I assign it to the struct C. But we have not talked about this in detail. It is just an operator overloading, but the nice thing, we can skip this. You have just to know this is a struct nested C here, and then let's concentrate about this one. That's more interesting. It says here struct B, so we are declaring here another nested struct. But this time we use final again. Is this allowed here? Yes, syntax looks fine. And then we have our base clause, which says C is also fine because we are inheriting from this. Here is no final word. So here we are allowed to inherit because here is no final. That's okay. And then you can see, okay, definition of nested class B and not declaration of a bit field member final. Okay, this one we have also not talked. You can skip this one as well. So here is now abnormal final usage, which means they are showing us the worst code now, what you can do with the word final, because it's not a keyword. So they start here with, again, we are declaring, they're starting with a struct. So when we start with a struct, we know, we are probably creating a struct, right? But look what we have here, final. So for the first time when you see that, wait a minute, what is that? And then you say, when you read here this documentation, okay, definition of a struct name final. Okay, here, which one is the struct name? This one or this one? Not so clear, right? From which you cannot inherit. But now you should be clear, because we learned this final word here must be in declaration here. First class K, this is struct. Then class head name, which means this one here is our variable name, class struct name. And then final, this would be here, this one here. So if you see the third one here, then it's clear what happens here. But still, even if it's clear now what this is, you see, using final in this way, it's really makes it harder to read, to understand what happens, and this get even worse in the next line. So let's read the next line. Struct, it says here again struct like here, it says here final like here, it says final like here, and this one looks almost the same. But why is this an error? Actually, because it is the same. Redefinition of struct final, we can see it here, struct final. We just learned this. So this error to identify is easy in this case, but here's something in it which is not so easy, what you would not really see instantly, because we have not talked about some other things here. Then this is the part, this part here. Let's go a little bit. Don't worry about it if you don't understand it in detail, because we have not talked about it. So which is, it says here, not a definition of a variable. So wait a minute. Can this be a definition of a variable when it looks like this one here? Actually, the answer is almost yes. But we have not talked about it because there is something called elaborated type specifier. We have not talked about this one in detail. And let's read this one first and then I explain it. Not a definition of a variable final using an elaborated type specifier. Yes, this one here would be this one here normally. Struct final, yes, they are indicating this one here as well, followed by an accurate initialization here. This would be our variable name. This would be our elaborated type specifier, and it would be normally an aggregate initialization, but it says all this kind of stuff what I just described you. There is a big not here. Not, it could be, but it is not the case. Okay, and what is this elaborated type specifier? Very short, I don't go depth because we have to talk about this a little bit more in detail. This elaborated type specifier means just if you have, for example, here class T, just you need here only the T here for this example. It is a class called T, and then here's our main, and I make a variable called T, but careful. This T is just a local variable name, not this one here. It has nothing to do with this one here. But I'm a little bit bad with naming and call it exactly like this one here. You can see, but they are not, like I said again, they have nothing to do with each other. But now what happens is, now I create here in this scope here from main. It starts from here because this is local. Here I want to create a new variable, but from this class here now. That's why I start with the type, which is the class name here. And then I call here any variable name. They call it little t now. All right. And you see, we get here an error. The local variable t is found. And this has something to do with this qualified name lookup or unqualified. We have not talked about this one in detail. But what happens is the compiler checks, oh, I have here t, but t is here defined as a variable, and you are creating with this variable anything, and this is not allowed. So what? So the question is now, okay, how I can create now a variable with the class, even I have created it with this one already. And now this elaborated type specifier comes into play. They say what you can do is just say class T. You mean not T, the local T here. You mean the class T, which is outside anywhere. And then you say T. Okay, finds, and then this lookup here, this name lookup, will the compiler, with other words, will go check, there is anywhere a class T. Yes, I found there indeed in the global space a class T. And then the local variable T is ignored, which means this one here is ignored. Right, so this means you can declare a variable name like this. Let's go back to our example. That was this one. So with other words, you could create a variable. This word final is our variable name, and this one would be our elaborated type, and this was just an aggregated installation, but could be also careful about this one. Looks also similar to a list initialization, so there are different kind of problems. So let's see, but don't worry if you don't understand this one. We will talk about this one later. Important is here again, the word final caused again a big problem because we used it this way. If we would use here anything else, would be a little bit more clear, more readable, and so on. Let's go here a little bit more here over to this one. It says here struct override final. What is the error before you read this one? Yeah, I think this one is not so difficult to see. The problem is override. Override is only used in functions, not with struct and classes, right? Don't use it there. When you have a function, you can use override, but not, and then you can use it only, careful, override means you are overriding a virtual function, so it must be also provided a virtual function there to override it. And what is this one here? Final. What is there a problem with this word final? I hope you identified it. There is a problem because this final means not, I'm using the word final specifier. This here is the class final. Here, the struct final, which I have defined anywhere there. Where is that? I don't know. Yeah, definitely here. And we have a problem. So I try to inherit from struct final here, which is final, right? This is here the word struct final. Careful. You can see again the name is all times trying to confuse, because if the struct here would be final, this word would be here before the colon. but it is trying to inherit from this one. The error is because this one was specified final. This one is the specifier. This one is the struct final. Arrow cannot derive from final base type. Yes, this is this one. Override is given context in a normal name. Yeah, this one here. So we have here even two problems. Okay, let's go here a little bit more to the foo example here. Again, here's a function foo. This one, I hope you remember what this brackets are. This is an indicator for an attribute. So let's go here. Here, this one, an attribute, as all starts all time, most time, I think, with this one here. And we see it not so often because it's more a compiler instruction most time, not all time, which means, yeah, the compiler sees this and then can optimize towards it and so on. But in the end, the compiler, yeah, decide what to do. And then we have here, again, what is that? Final. This is okay. So why is this okay here? What we are doing here actually? So actually we are taking a final and we're creating just a final variable. So you can see declaring of a variable named final. Yes, this one with the struct, this one final. That is absolute okay. That's nothing wrong. But again, final. Again, and now it's interesting, that is that what I explained to you here with this elaborated type specifier. This one is actually declaring a variable with the elaborated type specifier, which we have not talked so in detail. So you can see this time is okay. Look, they look almost similar. The only difference is this little thing here. And this one in a variable can confuse as well, because we know this one is allowed with list initialization, but in this case not. Interesting, right? And here you can see this one is allowed. It says declaring of a variable named final. Here the name is here. This one is our elaborated type specifier of type struct final. Yes, struct final using elaborated type specifier. All right, you see, I went only through this one, that you see how big problems can it make when we use the specifiers like final or override, which are not keywords. And because they are not keywords, which means they can be used for names, and then we have a big problem like this one here, which is more confusing than helping anything. Anyway, that's for this video, but again, very short. Final, the word final in general, if you use it like in this example here, it's very easy, straightforward. Use good naming, then all thing is very clear, straightforward and easy, because when you see final means just don't go further. Don't override this function, or don't, when if it's used with class struct, don't inherit. That's all about final actually. All right, with that said, I stop here the video. If you have any questions like all time, write in the comment section. See you in the next video, where we want to talk about abstract classes, which is actually this part here with pure functions and so on. So see you there. Bye, good luck, and like all time, have fun and never give up.